Deletion on a linked list is pretty straightforward, and it's the last case that we really have to tackle for a single linked list. So let's look at that. So we got our list, start, and this points to our first node, 103, 104, 105. Let me fix this a little bit. 105, and then finally this is our end, and this is our the end of our list. So we have our list, and we've got a couple of nodes, and then we've got 3 nodes in here with some info stored in them. How do we deal with deleting elements from this list? So there's really 3 cases that I think we're going to have to handle. So number 1, we got to deal with the problem if we just have a lone list where start is the only thing in it. So we got to deal with the case when we have a list where start is null. Why is that an issue? Because what if we had a list and we just had start, and start was pointing to null? In that case, we just got to return that the list is empty. So we just got to tell someone that the list is empty if that's the case. The second case we got to deal with is, what if we try to delete? I think I can change color. Okay, and we'll go with green. Alright, what if we try to change this element? What if this is the element that we want to delete? How do we deal with that case? Okay, I guess I'm going to be working in blue. So, delete first node. How do you delete the first node? Well, if we really want to delete the first node, we gotta move start's link to the next element in the list. So we gotta use a temporary pointer. And let's put a temporary pointer pointing straight to start. So what's that gonna be? Temp equal to start. And now we want to take this arrow, this link, and we want to point it to this node. So start needs to be pointing to the next element in the list, which would be start link. See, we're basically just skipping over the first node. And now this green thing's by itself. This is by itself now. So we can use this function called free, and we write free temp, and this will get removed. So that's how we deal with deleting something from the first node. Now let's say that we've got a situation, delete in between nodes. Deleting in between nodes. Let's go ahead and erase this mess here, and we'll draw back our regular list. So temp's going to be pointing to 103, and we want to delete this node, 164. So we're going to loop through the list, and then we're going to stop once we're here. So we're going to stop here. We're going to use a skipping pointer called P. We're going to skip through the list until we get to the node just before the node that we're about to delete. And then we're going to use a temporary pointer. And guess what? We're going to point it straight to the skipping pointer's link. So what does that look like in code? It's going to be temp equal to the skipping pointer link, p link. once that's set, now we just gotta change our arrow here to point to this node. So we're just going to reassign p link, the skipping pointer's link, equal to temp link. It's just going to put us 2 links ahead. And then we can destroy this node. Run free temp. That should be delete. Run free temp. Okay, and then what this would give us is basically a new clean list. Kind of clean. It looks like it's drawn sloppy, but can you see how everything is still connected? We still have connected list. We've just removed a node. So that's the theory behind deleting things in the list. And we're going to use the data that's being stored in the list to find the things we're going to delete. Let's see how we can implement this in some code. Okay, so I've copied the code from search into this file here. Basically, if you go to the last lecture and you look at this code that we used to build the list, I don't think it's going to be particularly useful to go through and rebuild all this code. So we're going to take insert and empty, insert at end, create list, and we're going to take the code from that. We're going to recycle it here. So I'm just going to go through, and then you can pause the video at the parts that you need. But to go back and rewrite all that, I don't think it'd be very constructive to the video. So we have a function. We're including standard library, standard input and output to print and get user input. We have our node data structure, and we're using 3 functions. So we're going to use create list, insert in beginning, insert at end, and then show list. And then we're going to need a function to delete a node, struct node, delete node, struct node, start int info. Okay, and I've added all this code in here. So this is our test. If all of our code is right, this will work. Right now it's not going to work, obviously, because we haven't put in the functionality for deleting a node. So we have a variable that we're going to use to store the user's choice, a variable to store the input that they enter, and we have our head pointer. We initialize it starting to null, and then we reassign it by building a list and setting it equal to the start pointer. Then I have this little while loop here. If you don't remember this, you can go back to the lecture on control and conditionals. So we get a number from the user, we process that number. If they put in 4, it quits the program. Otherwise, it enters this switch statement. So it processes the number that the user enters. So if the user enters number 1, it's going to come straight to here, and it's going to ask them to enter a node they want to delete, and it'll delete the node based on the info. And then if they enter a 2, it comes in here, and we can add a new node to the end of the list, and then 3, of course, is going to print out the entire list. So why don't we look at the functions that are involved in creating the list. So really, this is all the code that you really need to copy to create a list. So create a list is going to get the size of the list that the user wants to enter, and then we're going to get the first node, insert it into the empty list, and then until we've gotten all the user nodes, we're just going to loop through, get their nodes, and then keep on reassigning the start, and then return start back at the end. Here's the inserting an empty, and here's the inserting at the end of the list. Then here's the function for printing out the list. This is going to be important because we're going to use this, and we're going to use the same while loop over and over again. Look at where it keeps on showing up over and over again. So this one's going to stop just before the end. This one's actually going to stop at the end. So we're going to skip through the list, and we're going to print out all the info. So now we have to use the code that we got from the theory to make the delete functionality. So struct node, start delete node struct node start. Okay, so we're going to need a temporary pointer and we're going to need a skipping pointer. That's what I've been referring to P as. P is like our skipping pointer. It's the thing that allows us to traverse the list. Struct node star temp star P. Okay, so the first case that we got to guard against is if the list is empty. So if start equals null. Well, if start equals null, we want to print out that the list is empty. So print if the list is empty and return start. Yep. Okay. So that's the first case. If that happens, if we run into the case where someone tries to delete something from an empty list, it's just going to bounce out and give them back start. Now, the other case we had was case number 2, where the first piece of the first node was to be deleted. So the node immediately after start, a node immediately preceding start was the thing we're going to delete. So to do that, we gotta first use our temporary node and point that to start. And then we want start to skip over that first node. So we're going to reassign start to start link. So basically we just skipped over that first node and we have a pointer to it still. So now we can free that memory and return start. It's going to exit the function after that's done. Now we're going to have to bounce through the list because we have to handle a case where we're deleting in between nodes. So P equal to start. And we want to stop just before the node that we're going to delete. So we don't want to go all the way to the end of the list. So well, plink is not equal to null. And the condition that we're checking for is if the node just before the node that we're about to delete, if it's info, we want to stop at the node that we're just about to delete. So we want to check the info before we actually get to that node. So if plink info equals info, we're going to quit the loop. So this is just like when P stopped before the node that we were going to delete in the theory section. P equals plink. And now once we break out of this loop, well, maybe we skipped all the way to the end of the list. So maybe we never met that if statement. And if that's the case, we'll just check if plink is null. Then we'll print out element with %d not found in the list. So that just means that the data wasn't found, and make sure that we're breaking both of these with the new line character at the end of each print. Okay. Otherwise, we want to delete that node. Temp equals plink. Plink equals temp link free. Okay, so this should work. So we'll cd into, we're down in the terminal now. So we're going to cd into deletion. and G++ deletion .c -o proc, and let's run it. So 5, put 1, 2, 3, 4, 5, and let's delete a node. We'll delete the first node. And we want to show the list. So now we see that the node with the data with the info of 1 is gone. And then we're going to delete a node with 4 stored in it. So 2, 3, 5. There we go. So that's it on linked lists. Congratulate yourself if you made it this far. You're really, you're pretty far in data structures now. The only thing that you really need to understand is arrays, and at that point, you have the tools to basically understand any type of data structure in C from a very fundamental level. More practice, building lists, and working on things is all you really can do. If you like this tutorial, I'm putting out lots of little tutorials on C programming, and there will be more added to this course throughout the year. Have a great day. Like and subscribe.